Hello everyone, welcome to this course on Oracle Cloud Infrastructure Streaming Service. My name is Rohit Rahi and I'm part of the OCI team. In this course, we will describe the OCI Streaming Service, we will understand some of the streaming concepts, and then we'll create a stream and publish and consume messages. So what is the OCI Streaming Service? OCI Streaming Service provides a fully managed, scalable, durable storage option for continuous, high-volume streams of data that you can consume and process in real time. What are the use cases? Well, the use cases are for any kind of high throughput continuous stream of data you get and you want to process in real time. So this is very different from the traditional ETL extract, transform, load kind of data patterns. So anytime you have a large amount of data stream coming in, you can use streaming service. The use cases are shown here. So log and event data collection for any kind of web, mobile activity data ingestion, any kind of IoT data streaming for processing and alerts, or for that matter for messaging, for if you have a complex system and you want to decouple components of a large system and have sort of a topic and subscription in there where you can send messages through to a channel and then consume messages from that. You could use the streaming service. It's what are some of the characteristics of the OCI streaming service which make it different from other offerings out there? The first one I would say is it offers a managed consumers and managed consumer groups that help in offloading, load balancing, coordination and offset management. So you don't have to do all that yourself. We have a nice API which lets you do that, and we'll talk more about that. The service is accessible using the REST APIs, the console, the SDKs, CLI, Terraform. It's integrated with identity and access management for authentication and authorization, and then also has integration with monitoring service. So you out of the box you get various monitoring charts, and you can get more information, more diagnostic information about your streaming and publishing and consuming of messages. It's a very intuitive, simple and elastic pricing scheme we offer, so it makes it very attractive. You really don't have to pre-provision large amounts of capacity, etc. for using the service. So what are some of the key core concepts? The first concept is there is something called a message, and message is nothing but a 64-bit encoded record or array of bytes. So think of message as a record or a row in a database if you're coming from the traditional database world. There is something called a key, which is an identifier to group related messages like the message. This is also a byte array. There is stream, which is an append only log of messages. So think of stream as an ever growing data set, can have very high throughput, lots of messages when new records keep arriving at sometimes very fast pace. A topic is messages are categorized into topics. So think of topic as a database table. There's something called a partition. So topics are additionally broken down into a number of partitions. An offset in each message within a partition has an identifier called its offsets. Consumers can read messages starting from a specific offset and are allowed to read from any offset point they choose. So a picture always helps to describe when you're describing these concepts. As you can see here, there is a topic which has three partitions: partition 0, partition 1 and partition 2, and you can write messages. A publisher can write messages to each of these, any of these partitions, and these are the offsets. So the messages can go into any of these offsets, and using the offsets the consumers are able to read messages. Now the idea behind a partition is that each partition can be hosted on a different server, and this can be in different ADs. So this can be in partition 0 can be AD1, partition 1 can be AD2, and so on and so forth. This means that a single topic can be scaled horizontally across multiple servers in multiple ADs to provide performance far beyond that of a single server. And since the ADs share a very high throughput, low latency dark fiber network, there is not latency is not a problem. So you could spread these topics partitions out in a single topic across multiple ADs. So how do you create a stream? And we'll actually do this in the console. It's a very simple process to create a stream. Takes literally a few seconds. You provide the stream name, you provide the retention period in hours, and then you provide the number of partitions, and that's it. You provide these three values and you can create a stream. As we said earlier, a stream data is replicated across the entire region. So it's a regional service, and what that means is you can have an AD loss, but it's still your stream would be up and running. So it provides that built-in HA across a region in a particular region. Retention is in hours defines the time a message is stored on a topic before it is discarded. By default, we have a retention period of 24 hours, but this can be increased to 7 days as well. The throughput of an OCI stream is defined by a partition. A partition provides 1 MB per second data input and 2 MB per second data output, and you can see these values here when you choose the number of partitions. As you increase this number, it multiplies the total write throughput and the total read throughput. You can send 1000 requests per second to a partition. And the streaming service is secure by default. What that means is user data is encrypted both at rest and in motion. And you can read our documentation on how this works. When you push the data from the publisher to the streaming service, there's a gateway. You can encrypt that data using SSL, and then from there the streaming service manages its own encryption, and both at rest and in motion. So you can read all the details. Currently, you cannot change the number of partitions once a stream is created. So we recommend to allocate partitions slightly higher than your maximum throughput requirements. So this is a limitation. It will go away in the future, but just keep that in mind. So at this point, let me quickly show you how to create a stream. It's rather straightforward. So let me just go to the OCI console. Right here I am on the OCI console. The streaming service is part of the analytics section here. So click on streaming, and it brings up this this view here, and I have few streams I created earlier which are all in the deleted state. So to create a new stream, I would click on create stream. First thing it says is it asks me for a compartment. I'm using this training compartment, and then it asks me for a name for my stream. So I would say this is for I'm working for the finance organization. They need some kind of or let's say this is marketing. They're kind of some event they are running, and they want to collect some data on that. And then the other two settings are for retention period in hours. I can say 24 hours is fine, and number of partitions, because I'm just trying to test, so 1 partition is fine. In case you have a spiky application, probably you would need to increase the number of partition. And with that, I just click on create stream, and this would take roughly 10 seconds or so, and the stream would be created. Now once the stream is created, we can test it out by producing some test messages here, and it's pretty straightforward. Or I could write an application to do that, but let me go back to the slides, and we'll come back here again. So along with we just saw the core concepts and how to create a stream. Very straightforward. Now what are these producers and consumers? Because this is also a core concept you need to understand. So producer is nothing but an actor who creates new messages. A message is written to a specific topic, as we saw earlier. A consumer basically reads messages. Now in general, consumer subscribes to one or more topics and read the messages in the order in which they were produced. Consumers keep track of which messages it has already consumed by keeping track of the message offset. Remember, we said every message has a unique identifier called the message offset. It's a unique identifier, or you could also say it's the location of a message within a stream or a partition. By storing the offset of the last consumed message, a consumer can stop and restart. So that's the beauty of the model. They don't really have to get lost, because it's keeping a track of the last consumed message. There's also this concept called a consumer group, sometimes also just called a group. So consumer group is a set of consumer instances, sometimes we also call them instances, just instances that coordinate to consume messages from all the partitions in a stream. Each partition is only consumed by one member of the group. So let's see how it looks like from conceptually. So let's say we have a topic with 3 partitions, as we saw earlier. So there's partition 0, partition 1, and partition 2. So what we could do is we could create a consumer group, and we can have 2 consumers as part of that consumer group, consumer 0 and consumer 1. And remember, these are instances. So consumer 0 can consume message from the partition 0, because a single consumer can only read messages from a single partition, or single or more partition, but it has to have one partition can only be consumed by one consumer. In this case, this consumer 1 actually can access 2 different partitions here. So there's a partition 1 and there's a partition 2 which it can access. Now, partitions are reserved for specific instances in a group. While an instance maintains membership to a group, calls to get messages will return messages from only partitions reserved for that instance. So one consumer can have multiple can read from multiple partitions, but one partition can only be part of one consumer group, right? So partition to consumer is one-to-one relationship. Consumer to partition is one-to-many relationship. An instance commits offsets of processed messages to ensure that they are not processed again by other instances in the same group, right? Makes sense. And then partition assignments are rebalanced as consumers join or leave the group. So if you add more consumers, if there's a failure, or if this consumer goes away and other consumer joins this group, we do a rebalancing. So this is something which is done by the service, and so it's a really nice feature to have. Now, how you publish and consume? How do you publish and consume messages? Once a stream is created, and we just created one on the console, and it's active, you can publish messages. For publishing, you can use the write API. We will, in this course, we are not going to use the API, but we'll just do that very quickly on the console. The message will be published to a partition in a stream, right, as we saw earlier. If there are more than one partitions, the partition where the message will be published is calculated using the messages key. Now remember, message always has a value and a key can be null as well. So messages produced with the same key, not null, keep in mind, will get returned to the same partition. So that's one way to organize and group together your messages, have the same key for those messages. Consuming messages require you to create a cursor, and cursor is nothing but a pointer to an offset in a partition from which you want to start consuming messages, and use the cursor to read messages. And as we discussed earlier, this is one way to consume messages. You control partitions and offsets and you read data. The other way is to use consumer groups, and consumer groups simplify application development by offloading load balancing, coordination, and offset tracking. So all that is taken care by the API. So you really just create your consumer groups, and then you can start consuming your messages. What are some of the design considerations? OCI Streaming Service supports message retention up to maximum of 7 days. So keep that in mind. After that, messages are discarded. The maximum message size supported is 1 MB. Each partition can handle up to 1000 emit API calls per second and 5 read API calls per second. Each partition can support up to a maximum total data write of 1 MB per second and a read rate of 2 MB per second. We saw this earlier. Each tenancy has a limit of 5 partitions, and you can request more. So let's go back to the console and write some messages. So if I go back to the console, I can see my stream is created and it's active, and I can produce test messages. So I click on produce test messages, and I'm not using an API to do that right now. So I click, first message. I produce my second message. I can produce another message. I can produce one more message. And if I refresh now, I can see that these messages are all published into my stream, and you can see that the key is null because I didn't specify any key values. The offset is 0, 1, 2. These are unique identifiers, and because I have only a single partition, my partition is all partition 0, right? Because that's the only partition I have. Now this service is also integrated with monitoring, so you can see a few of the monitoring charts here. There is put messages latency, put messages throughput, how many messages are put per second, records per second, throttled if there are any of the messages throttled if you go beyond, let's say, the 1000 API calls we said, and then which it supports per second. There is the success rate, the failure rate, etc. And the same thing for consume monitoring charts. You can get the message latency, throughput, request per second, etc., right? So this is all nice if you want to look at your streams and figure out how your messages are getting produced, consumed, get some more telemetry, get information about your streams and messages. So in summary, the OCI streaming service is fully managed, scalable, durable storage option for continuous high volume streams of data that you can consume and process in real time. It has support for managed consumers and consumer groups, makes it really nice. It's a nice feature. It's integrated with identity and access management, where you can control authentication and authorization, and then it also has integration with monitoring for getting a lot of telemetry information. So this is the sort of the capabilities we support today, but there is a lot of exciting things which are coming out pretty soon. These include Kafka compatibility for reading and writing, Kafka Connect compatibility, private virtual cloud network VCN endpoints, because today you create the stream, it's sort of not behind a VCN, but in future you would be able to do that. And then also an option to store your messages into object storage, so you can archive your messages for longer than 7 days, because today there is a limit of 7 days, and after that the messages are discarded. And there are many more features, but these are some of the things which are coming out pretty soon. So again, thank you very much for joining me on this lecture on streaming service. I hope it was useful.